This is how many real data engineering projects start. Not with Kafka, not with billions of clean data, not with a perfect cloud architecture, but with a folder full of messy Excel files. One file is called Sales Jan Final Excel, another is called Sales January Final Excel, another has three header rows, another has different column names, and another has missing values. And somehow, every week, someone manually copies all of this into a one master report. Today, I am going to turn that messy Excel process into a real Spark data pipeline. But I want to be clear, I am not going to pretend Spark magically solves Excel chaos. A good pipeline needs ingestion, standardization, validation, bad record handling, clean tables, and a final business output. So by the end of this video, we will go from Excel hell to a proper bronze, silver, and gold data pipeline. Hello everyone, welcome to Big Data Factory. I am Ranit and I have over 4 years of experience working as a data engineer. If this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. Let's imagine a business team sends sales report every week. The process looks like this. Regional team uploads Excel files. Someone opens each file manually. They copy and paste rows into a master spreadsheet. They fix column names by hand, they remove bad rows manually, then they calculate revenue. Then they send a report. This works when there are 5 files. It becomes painful when there are 50. And it becomes completely unreliable when there are hundreds. The problem is not just Excel. The problem is manual work. Manual work means inconsistent rules. No audit trail, no automatic validation, no easy backfill, no repeatability, and no one is fully confident on the final output. So the goal is simple. Take this manual Excel process and turn it into a repeatable data pipeline. Here is the before version. Excel files, manually copy paste, master Excel, manual formulas, manual report. And here is the after version. Excel landing folder, raw ingestion, standardized files, Spark cleaning, data validation, quarantine for bad records, clean parquet tables, good revenue tables, and final dashboard or report. I will use Spark for the scalable transformation part, but first we need to solve a practical problem. Spark is great for processing structured data at scale, but Excel files are messy. So the first step is not transformation. The first step is landing and standardization. The pipeline will have 4 layers. Layer 1, landing. This is where original Excel files arrive. We do not change these files. We keep them as is. Why? Because raw files are evidence. If something goes wrong, we can always go back to the original input. Layer 2, bronze. Here we convert each Excel sheet into a standardized row format like CSV or Parquet. We also add metadata, for example, source file name, sheet name, ingestion timestamp, batch ID, and row number. This metadata is extremely useful for debugging. If one bad record appears in the gold table, we can trace it back to the exact file and sheet. Layer 3, silver. This is where Spark cleans and standardizes the data. Column names are fixed, dates are parsed, currencies are standardized, bad values are handled, duplicates are removed. Layer 4, gold. This is the business ready layer. Daily revenue, revenue by region, revenue by product, failure record summary, and audit tables. This is what the dashboard or report will use. Now let's look at the kind of mess we are dealing with. In one file, the columns are order ID, order date, product, quantity, amount. In another file, order ID, date, product name, quantity, sales. In another file, ID, transaction date, item, units, revenue. These all mean similar things, but a computer does not know unless we teach it. This is where many beginner projects feel unrealistic. They assume every file has the same perfect schema, but real business files often do not. So we need a column mapping layer. For example, order ID, order underscore ID, and ID all becomes order underscore ID. QTY, quantity, and units all become quantity. Amount, sales, and revenue all become revenue. This mapping turns messy business language into a standard data model. The ingestion step does three things. First, it reads each Excel file from the landing folder. Second, it converts each sheet into a structured raw table. Third, it adds metadata so every row gets extra columns like source file, source sheet, ingestion time, batch ID, source row number. This may not look exciting, but it is one of the most important parts of the pipeline. Because when something goes wrong, metadata saves you. Without metadata, a bad record is just a bad record. With metadata, you can say the bad record came from this file, this sheet, this row, in this batch. That is production thinking. Now Spark comes in. The bronze data is structured enough for Spark to process. In the silver layer, we clean the data. First, standardize column names. Second, cache data types. Order ID should be a date. Quantity should be a number. Revenue should be numeric. Third, clean text fields. Country names should be consistent. Product names should be trimmed. Payment status should have user accepted values. Fourth, remove duplicates. If the same order appears twice, we should not double count it. Fifth, split good and bad records. This is important. A beginner pipeline often fails completely or ignores bad data. A better pipeline separates bad records into a quarantine table. Good records continue. Bad records are stored for review. This means the business get a report and the data team still has visibility into what failed. Now let's add validation rules. For this sales pipeline, I would check order ID should not be null. Order date should be valid. Quantity should be greater than 0. Revenue should not be negative. Country should be in the accepted list. Currency should be present. Source file should be tracked. Duplicate order IDs should be handled. If a row fails one of these rules, we add it to the quarantine table with a valid reason. For example, invalid date, missing order ID, negative revenue, unknown country, duplicate order. This failure is useful because it turns bad data into something actionable. Instead of saying the pipeline failed, we can say 23 rows failed because order date was invalid. That is much more useful. Now notice something. The value of this project is not just that we used Spark. Anyone can write a Spark transformation. The real value is that we took a messy human process and made it repeatable, traceable, and testable. That is why this is a good data engineering project. Because many real companies do not start with perfect data platforms. They start with messy reports. And data engineering turned that mess into reliable systems. Now let's build the final business layer. In the goal layer, we create business ready tables. The first table is daily revenue. It has date, region, total revenue, number of orders, average order value. The second table is product performance. It has product, units sold, revenue, number of orders. The third table is a file audit table. This tells us which files are processed, how many rows were read, how many rows were passed validation, how many rows failed, and when the file was processed. The fourth table is the quarantine summary. This tells the business and data team what needs to be fixed. This is important because a real pipeline should not hide the bad data. It should make bad data visible. Now the final output is no longer a manually updated Excel master file. It is a clean data product. A dashboard or report can now read from the final goal tables. Revenue updates consistently. Bad records are tracked. Historical data can be reprocessed. New files can be added without manual copy paste. And if a number looks wrong, we can trace it back to the original source file. That is the transformation, not just Excel to Spark, but manual chaos to a reliable data pipeline. So what makes this pipeline better than a basic tutorial? First, we keep all raw files untouched. Second, we standardize messy schemas. Third, we add a source metadata. Fourth, we use Spark for scalable cleaning and transformation. Fifth, we validate business rules. Sixth, we quarantine bad records. Seventh, we create audit tables. And eighth, we produce business ready goal tables. This is what turns this from a simple script into a real data engineering project. The main lesson is this: real data engineering is not always glamorous. Sometimes the job is not building a massive real time platform. Sometimes the job is taking a broken manual process and making it reliable. And that is valuable. Because business do not care whether you use the most trendy tool. They care whether the report is correct. They care whether the pipelines run again tomorrow. They care whether the bad data is caught. And they care whether the numbers can be trusted. So if you are building data engineering projects for your portfolio, do not only build perfect demo pipelines. Build something messy. Build something realistic. Take ugly files, standardize them, validate them, track them, and turn them into clean business tables. That is the kind of project that feels much closer to real work. Comment spark and let me know in the comment section whether you have experienced it or solved this type of production scenarios. If this helped, drop a like and subscribe to Big Data Factory. This is all for today. I will meet you in the next video. Till then, keep learning and keep building. Bye bye.